today's video, I'm gonna discuss about operations on algebraic fractions. And what are these algebraic fractions? But before I'm gonna start discussing about algebraic fractions, or I must discuss first the operations on fractions before we're gonna go to algebraic fractions. Okay, so first, okay, we have proper and improper fractions. We have 3 over 2. So this is improper fraction. Improper is because the numerator is bigger than the denominator. Okay. So, but if you have like 3/5 like this, so the numerator is smaller than denominator, so that's proper fractions. Okay. So we also have what we call similar and dissimilar fractions. Similar fractions are having the same denominator. Like, shall we say 3 over 2, and then 1 over 2, and then 4 over 2. Okay, they are similar fractions because they have the same denominators. Okay, whereas the dissimilar fractions are fractions with different denominators, like 3/5, 1/2, and 2/3. Okay, so they're dissimilar fractions. Okay, so we are going to solve this stuff as we go on with this video. Okay, I'm gonna show first the operations on fractions. Okay, so we have addition of fractions. Now, similar fractions, so like shall we say 2/3 plus 4/3. Okay, so 2/3 and 4/3 we have there. If they are similar or having the same denominators, just copy denominator, which is 3, and then add a numerator. So 2 plus 4, that is 6. Okay, and 6 divided by 3, since we can still divide the numerator with denominator. 6 divided by 3, that is 2. Okay, so whole numbers are also fractions because they are understood to have the denominator of 1. Okay, so another one, if we have like 2 over 7 plus 3 over 7. Okay, so this one, same denominator, so we'll just have to copy it, 7, and then 2 plus 3, that is 5. Can we divide 5 by 7? Do not divide 7 by 5. Always the numerator divided by denominator, okay? Can we divide 5 by 7? No. So this one is in simplest form, so the answer is 5 over 7, okay? Now, if they have different denominators, shall we say 2/5, okay? And then 4/7, okay? So this is the example. Okay, so shall we say adding the fractions with different denominators. Look at this. So we cannot just like simply copy them, 5 and 7, no? Anyway, what you're gonna do is just to cross multiply, okay? So this one here, 7 multiplied to 2, that's 14, right? 7 times 2 is 14. And then copy the sign, that's plus, okay? And then 5 times 4, like this. 5 times 4, that is 20, okay? And then over, multiply them. 5 times 7, that is 35. Okay, so this one, 14 plus 20, that is 34. Over 35. Okay, so this is now the simplest form because the numerator is smaller than denominator. Okay, next one. Same rule. Okay, so 2 times 4 or 4 times 2, that is 8. And then, what's the sign? Plus. 7 times 3, that is 21. Over. Okay, 7 times 4, like this. And then 7 times 4, that is 28. Okay, so 8 plus 21, that is 29 over 28. And since numerator is bigger than 28 or denominator, so 29 divided by 28, that is 1, right? Because it's a 29 divided by 28, 1. Okay, 1 times 28 is 28. And then minus, so that's 1, right? So our answer must be whole number here, and then 1 here. This one will be the numerator. Denominator here, 28. Okay, so that's it. That's the simplest form. Okay, there we go. Let's go to subtraction. Same rule with addition. But the thing is, what differs them is just the sign, okay, which is minus. Okay, so shall we say 2/5 and minus what's this? Sorry, this is like 4/5 minus 1/5. Okay, same denominator, proceed, copy 5, and then 4 minus 1, that is 3. Okay, 3/5. It's in simplest form because the numerator, which is 3, is smaller than the denominator. Okay, so this is now the answer. Now, shall we say 7 over 11 minus 2 over 11. Okay, so same denominator again. Copy. And then 7 minus 2, that is 5. Is this simplest form? Yes. Okay, because numerator is smaller than denominator. What if they are different in denominators? Like, shall we say, okay, like this. Shall we say 2/9? Okay, next. Again, same rule, okay? Like this, multiply, and like that. So 5 times 4, that is 20, okay? And then minus, because the sign is minus. And then 7 times 1, that is 7. Over 7 times 5, that is 35, okay? So this one, 20 minus 7 is 13, over 35. So this is now the final answer. Numerator is smaller than denominator, so it's simplest form, okay? Next one, here, 9 times 7, that is 63, right? So this one is 63, minus, because it's minus sign. 11 times 2, that is 22, okay? And 11, like that. And then 11 times 9, that is 99, okay? So there we go. 63 minus 22, that is 41 over 99. Okay, simplest form? Yes. Okay, so there we go. We cannot reduce them to lowest term because there is no common factor between 41 and 99. Okay, there we go. So let's go to multiplication. Now in multiplication, we don't have to consider the denominators here, okay? What you're gonna do is just to multiply the numerator to numerator and denominator to denominator. We only consider the denominators in addition and subtraction, okay? So multiplying the numerator and numerator, 3 times 2, that is 6. And then this one, 5 times 3, that is 15. Proper fraction, correct? 6 over 15. Numerator is smaller than denominator. But take note, there is common factor between the numerator, which is 6, and denominator, which is 15. And their common is 3, okay? So we're going to reduce this one by dividing the common factor, which is 3. Okay, so divide by 3. So we have there 6 divided by 3. We have 2. 15 divided by 3, that is 5. Okay, so in the here, you can also do that one, the cancellation. You can cancel 3 and 3. Okay, so the answer is like, this is 1, 1. So 1 times 2 is 2. And then 5 times 1 is 5. Okay, so you can cancel if there is common factor in numerator and denominator lang ha. We don't have like common factor and then reduce numerator, no. Numerator, denominator. It's either numerator, denominator, numerator, denominator. Or numerator, denominator, numerator, denominator. We don't say numerator, numerator. Cancelling the common factor, okay? So there you go. That's it. That's multiplication. It's just very easy. Numerator times numerator, denominator times denominator. Okay. Let's go to division of fractions, okay? So, division of fractions, just copy the first, which is 3/5, okay? And then change the sign to multiplication always. The division sign is changed to multiplication. And then take the reciprocal of this one. So, we have 7 over 4. That's it. And then proceed with the multiplication rule. Okay, numerator to numerator, denominator, denominator. So, we say 3 times 7 is 21. And 5 times 4, that is 20. Okay, so since the numerator is bigger than denominator, we can divide this. 21 divided by 20, we have 1. And then the remainder is 1, and then divided by 20. So this one is the simplest form of this. Okay? Next. Shall we say, we have, okay, so this one. So we have 4/5, okay? And then multiplication, then take the reciprocal of this one. So we have 11 over 20. There you go. And here we can still, numerator, denominator, we can divide this by 4, which is common, okay? So 4 divided by 4 is 1, 20 divided by 4 is 5. So 1 times 11, rule. 1 times 11, 11, 5 times 5, okay? 5 times 5 is 25, okay? There you go. Do they have common, 11 and 25? No. So this is already simplest form. There you go. And I think we can now proceed with the rational expressions, operation on rational expressions or algebraic fractions. Okay, these are what we call examples of algebraic fractions. Okay, so you can see there are already like variables in numerator and denominators. Okay, now how do we apply the operations on this one? So let's take for example, okay, so in this case, okay, so let's have the same denominator first. Okay, so shall we say like this, 2x over y plus 4 over 4 over y. So since they have the same denominator, just copy that, okay? And then 2x plus 4, we cannot add them as 1, so we just have like 2x plus 4, okay? There you go. So this one is 2x plus 4 over y. Now, if we have like this, look at this. They have the same, what's this? They have the same variables which are a and b, but the other fraction has a numerical coefficient of 2, okay? So what you're gonna do with that is just multiply, let's find the LCD anyway. Or, anyway, it's like this. We have AB, but this one has 1 and this one is 3. So, what is not here but it's here, the thing that is here and not here must be multiplied on both numerator and denominator, okay? So, we'll just have to multiply it with 3 and then multiply it with 3 to make the same, okay? So, the rule is, okay, so we have now 3x times 3, we have 9x, right? 9x and then over 3ab. And then plus 2x over 3ab. Okay, there you go. Now, same denominators. We can say 9x copy 3ab. Okay, same denominators. And then add the numerators. Since same or similar what's this? Expression, 9x and 2x, they are similar. It is because they have the same variables with the same exponent of 1, right? So we say 9x plus 2x, we just add the numerical coefficients, 9 and 2, we have 11x over 3ab. Okay, so this is the final answer. Now, what if like this? Okay? Now, what if like that? Okay? You can just, anyway, the denominators are not the same. Okay? But you can do like this, like that, and like this, apply that. But the thing is, there are two common denominators, I mean factors of the denominators, which is a and a, right? So, what you're going to multiply here and here would only be the y and z, okay? And then like this, okay? So we can proceed now, 5xz, okay? Z times 5x is 5xz. And then plus, since there's already a here, so we say y times 3b, so we have 3by over, okay? Over. Since there is common a, multiply y and z, so zy. Just copy the common, okay? And multiply the not common, so zy. We have there, okay? So this is now the final answer. We cannot add 5 and 3, it's because xz and by are different, okay? So we can just have 5xz plus 3by, okay? Over ayz, okay? There you go. Next, same with minus, okay? Same with minus. Let's use this one with minus 2 or subtraction. Okay. Minus. But before that, we need to have like the common, like 2x over a minus 2y over a. Okay, so since the same denominator, just copy denominator, which is a. And then, since you cannot minus 2x with 2y, or 2 and 2, it is because x and y are different variables. Okay, so we'll just have to proceed 2x minus 2y over a. That's it. Okay, there you go. So, what if like this? Again, same rule in addition. Same with addition and subtraction of fractions, there's the same rule. What is not here, but it's here, but here. So, that's the thing that you are going to multiply. A is common, so that's it. Just get that. So, we say a. Okay? And then z, multiply it here, and then y, multiply it here, and then multiply y and z here. So, we say zy. Okay? Copy the common, and then multiply zy. And z times 5x, we have 5x z. And then minus, copy the sign, 3b times y, we have 3by. That's it. we cannot again deduct 5 and 3. It is because xz and by are different variables. Okay, there you go. Multiplication. What if in multiplication? Multiplication, same rule with the basic fraction multiplication. So 5x ay times 2x y over z b. Okay, so shall we say like that? Now, numerator. So we say 5 and 2. Numerical coefficients first. 5 and 2, 5 times 2, that is 10. This one is multiplication, right? Okay, and then x and x, multiplying that, we have 2 because there's understood 1. When you are multiplying loss of exponents, multiplying same base, add the exponent. So there's 1 and 1, so that's why it's 2, x2. And then, since there is nothing with y, just one y there, copy that. And then, ay times zb, we say ay zb. Okay, we cannot multiply or just raise the exponents because they are all different variables. Okay, there you go. Or you can just you can also say abzy or abyz, same, because anyway they're just multiplication. Okay. Next, with division. Same rule with division. Like, shall I say this one? Let's have this. Division. Same rule with the basic fractions. We say 5x over ay, and then change the division sign to multiplication. Take the reciprocal. We have zb over 2xy. You get it? And then now you can proceed with multiplication. We say 5x times zb. We have 5x zb over ay times 2x y. So a 2x. So we say 2x a, and then y and y same, 1 1. Okay, multiplying that, we add exponent, so y squared. There you go. Okay, that's it. Now, let's try to add, subtract, multiply, and divide rational exponent, rational or algebraic or rational expressions, rational expressions with factors. Okay, binomial factors. Shall I say a plus b Okay, shall I say like this? Look at that. They have binomial factors. Now, if you are going to have like this, okay, I'll have the factored form first, and then later on, we're gonna do the factoring and then do the cancellation. Now, since this one is already factored form, if you can see like this, okay, and since this is parenthesis, means multiplication, and this is also parenthesis multiplication, you cannot cancel like here, numerator from here and denominator here. You cannot cancel that. You can only do that one with multiplication, okay? Since why is that so? Because there is the plus sign here, or plus and minus, you cannot do that, okay? Now, but in here you can cancel if there are the same stuff inside the parentheses, okay? If there are things that are the same, you can cancel them, okay? So there you go. So here a plus b, the whole a plus b quantity, and then a plus b here. Because when you're going to divide that, that will always give you 1 anyway, okay? So the remaining would be x plus y over x minus y plus a minus b over x minus y. Now, same denominator, right? X minus y. Copy that. So we say x minus y, and then x plus y plus a minus b. You can just say x plus y plus, okay, a minus b. That's it. You cannot add all of this one in one stuff because they are all different variables, okay? There you go. Same with minus, you can also apply that. Shall I say it's minus, okay? Okay, shall I say it's minus, it's not plus, okay? Now, the same stuff, minus, you cannot cancel here, the numerator here and here, or numerator here and here. No, you cannot do that because this is minus. Plus and minus, you cannot do that. But if in here, in one stuff, in the other side, if there is this all multiplication sign and then there is the same numerator and denominator, you can just cancel them. Okay? And then the remaining again is x plus y over x minus y minus a minus b over x minus y. Now, this one are having the same denominators, which is x minus y. Copy that. Okay? Next, since they're all different variables, we can say x plus y, and then this minus sign will be multiplied. This is understood one here. Multiplied to all the quantities inside. Okay, so negative 1 times a positive, so we have minus a. Okay, remember the multiplication of operations on signed numbers. And then negative 1 times negative b, that gives you positive b. That's it. Okay, so there you go. The answer is x plus y minus a plus b over x minus y. Okay, there you go. With regards to the answer, if there is like the two binomial stuff like this, it's either you can have the factored form or check the choices. In the choices, if the answers are in a factored form, or if not, there is what you call the expanded form. So I'll be going to teach you later on with that expanded or factored forms. Okay, there you go. Now, shall we say multiplication? Okay, multiplication. If it's like this, okay, there you go. Shall we say like that? If it's like this, you don't need to cancel and stuff. I mean, you can cancel here, numerator, denominator, numerator, denominator, like that. Because anyway, this is multiplication. Now, but the rule in multiplication, since there is no same here, numerator, denominator, oh, yeah, you can have like this also. And after that, since you cancel this one the same, you can proceed now with multiplication because they are not the same anyway. Even though they have the same denominator, you cannot cancel that because they're both denominators, and you cannot copy that because this is multiplication. So you just have to multiply that. We have x minus y, okay, and squared. Y squared because there is x minus y 1, x minus y 1. Multiplying same base. This is considered one base, one base. And they're just the same. So just add exponents. That's why it's x minus y squared, okay? And then just copying the upper part or the numerator, just copy them because you can say x plus y and then a minus b. Multiplication. Now, you always have to check in the choices. If you encounter this kind of problem, you always have to check the choices. In the choices, if the choices are stated in factored form. This is what's called factored form, okay? But sometimes in other tests, they give what's this expanded form. Now, how are you going to get the expanded form of this one? Okay, so just have to do the FOIL method. X and a, so we have ax, and then x and negative b, so we have negative bx, and then a and y, we have ay, and then y and negative b, that is negative by. Okay, there you go. And then expanding this one, expanding this means x minus y times x minus y, right? So x and x, so we have x squared. And then I explained this one in the special products and factoring. Anyway, but let's just use the FOIL method. And then this one, x and negative y, we have minus xy. And then this one, negative y and x, so we have minus xy again. And then minus y times minus y, that is plus y squared. Since this one are just the same, our final answer would be ax minus bx plus ay minus by over the same negative xy. So understood, there's one here in algebra. If there's nothing, that means 1. Okay? So 1 and 1, we have x squared minus 2xy plus y squared. This is our final answer. You always have to check in the choices if it's in factored form or in expanded form. This is what you call the expanded form in the choices, okay? So that's the the trick there, okay? There you go. Next, let's try to do division. Division is just the same as earlier, okay? Shall we say this one is division? Again, so you have to cancel that, and then division, change that. We have x plus y, copy the first x plus y over x minus y, change the division sign to multiplication, take the reciprocal, so we have x minus y over a minus b. Now, in this case, we have the numerator x minus y and denominator x minus y. We can cancel that because this is multiplication. Okay? So this is 1 and 1. So the final answer would be x plus y times 1. We have x plus y over 1 times a minus b. We have a minus b. This is now the final answer. Okay? There you go. That's how we do the division of rational expressions. Okay? There you go. Now I'll be going to explain more about factoring on my next video. So thank you so much, guys. I hope this one helped you a lot. And see you in my next video. This is Teacher Seppi. Stay safe, everyone. God bless. Bye-bye.